My name is David Ladner. I'm a professor of environmental engineering, and it's fun to be with you today. And Kelly, go ahead and introduce yourself too.
All right, hey y'all, I'm Kelly. I'm a senior environmental engineering student. I've had Dr. Ladner for one of my classes, and this is going to be a really fun activity, so I'm really excited for y'all.
We are coming from the environmental engineering side, as we both mentioned. So what is environmental engineering? We're focused on the whole world. This is Spaceship Earth. Did you guys know you were on a spaceship? Yeah, we're all on a spaceship because we're floating out in space, and you know what? We don't have any other spaceship to go to. We got to take care of this spaceship and make sure that it keeps doing all the things that we need it to do, and make sure that we don't hurt it too badly so that we can keep going. Now, on my map, I have all these locations. These are different places for environmental, where we can see environmental engineering in action. And so let's zoom into Greenville, South Carolina. And I want to take you over to, well, here's Greenville right here, but there's an important place or an important thing related to Greenville that's over here to the west a little bit on Lake Keowee. You might drive by this place one day. This place is what's called a drinking water treatment plant here in, it's actually in 6 Mile, South Carolina. But it is taking water out of the lake here on the left and treating it. In fact, if you're on a boat on the lake, you might pass by this big building. This is the intake structure. So there are big pumps inside this building that are pushing the water in a pipe along this road, and it goes over land all the way to this drinking water treatment plant. And we can see this, the different parts of this plant right here. The water goes here first, and that's where we add some chemicals. We call them coagulants and flocculants. And then inside here, the water gets mixed with these big paddle wheels that turn the water over and mix all the chemicals together and cause all the particles in the water to stick together. And then those particles settle out in these big tanks called sedimentation basins. So particles are settling out, and you can kind of see this circular thing. That's because there's a big arm at the bottom of the tank that spins around slowly and pushes the sludge to the bottom of the tank, because we're taking out the particles and it turns into sludge. And then the purified water comes over here and it falls through these filters. So right here you can count them: 1, 2, 3, 4, 2, 4, 6, 8, 10, 12, 14, 16 filters in this drinking water treatment plant that are filtering out those particles or any particles that remain after sedimentation. And then right inside here, inside this building, is where chlorine is added. And you probably all know about chlorine because you've been to a swimming pool and you know that chlorine gets added to make sure the pool water doesn't have bacteria that could harm you. Well, it's the same for drinking water. We add a little bit of chlorine, not as much as your swimming pool, but we add a little bit of chlorine to kill any remaining bacteria that make it through the process. And there we go. This is one example of what environmental engineers do.
Well, a lot of environmental engineers do either wastewater or water. So Dr. Ladner, he focuses more on the water side. And then we have another professor who focuses more on the wastewater side. So water is coming from like natural bodies of water, like lakes or streams or something like that. And it goes into the drinking water plant to be distributed to people. And then for people, you know, you flush a toilet, you wash your hands, you take a shower. All of that water goes to the wastewater plant to be cleaned up, to take all that nasty stuff out before we release it back into like a lake or a stream or something like that. And then again, it's just a big cycle. So water and wastewater engineers are basically a big cycle of the human interaction with the environment. And we make sure that whatever we put in the environment is safe, and whatever we take from the environment is safe for human consumption. So that's really what we like to focus on a lot of the time.
Open your hot chocolate packet just at the top and take just a little pinch. We don't want to put too much in our water, otherwise we'll make it too dirty. Now, if you were out at the lake or a stream or something like that, and you've had some water, you'd say, oh man, that water looks muddy. And yeah, water out in the environment often has mud and sediment. We call it sediment, dirt, clay, and there'd be bacteria in there too. So we need to remove all that stuff. So that's what this experiment is about. Now this is a syringe. Maybe you've dealt with a syringe before, but you know, you can just pull the plunger in and out a few times and get used to how it works. And then you want to push the plunger in all the way, so it looks like that, and then insert it into your glass, and then pull the plunger out while the tip is in the water, and get some of that dirty water into your plunger. Don't pull it all the way out, otherwise you'll spill the water. But now my syringe is filled with water because the plunger is out. Now this is a syringe, yes, but it's also a pump. This is a manual pump, one of the simplest pumps that there is out there. And you know, to treat water, we need a pump, and so our syringe is our pump. Now you also have the filter. No, actually, first what I want you to do is deliver a little bit of water. Take one of your vials and deliver some of this dirty water using your syringe into that vial. And when we do experiments, this is what we call our control. This is the water that did not get treated. And we need to be able to see what it looks like when it doesn't get treated so that we can know if our treatment really did anything. Now we're ready. We have our control done. We're ready to do our filtration. So take your syringe filter and notice that it has like a big side and a small side. The big side is the one we want to connect with the syringe. And then it like twists on. It's almost like a screw and a bolt, or a nut and bolt. Twist it on. You don't have to get it too tight. Get it snug, but don't twist it too hard, otherwise you might break it off. But now that your syringe filter is on your syringe, you're ready to take your other vial that does not have anything in it and deliver your water through the syringe into the vial. Now, if you put too much hot chocolate in your container, it might be really hard to filter, because what's happening is the hot chocolate has particles in it, and the particles get filtered out by the syringe because the syringe has very tiny holes. But if you have too many particles, too much hot chocolate, then it'll block the holes of the syringe and you can't get the water through. But hopefully everyone was able to do it. And if you were, then the thing to do would be to just pick both of them up and to compare them. And I can show you mine right here. And I think it's pretty clear on the camera that one of them is quite clear and one of them is still cloudy.
So if this is representing our body of water that we're taking, like our lake, what he said, our syringe was our pump. We are manually pumping, but obviously in a water or wastewater treatment plant, we have automated pumps with like mechanical stuff. And then these, remember those big filters that he was showing you? He was counting like 12 on the map. These are those kinds of filters that filter out all of that bad stuff that we want to catch. And then on the filter, if you read it, has lots of different bigger words that you may not know about. But the thing that Dr. Ladner really wants to point out to y'all is that it says ion chrome 0.45 micrometers. So that is the size of the pores that are in this filter that we have, and then any particles that are bigger than the 0.45 micrometers will be captured. And so those are the things that we want to stay in the filter and not let through. And that's wherever we got the clear water. So all that bad stuff, we got caught in the filter, and then we get clean water. So that's really how this experiment is working. And on a larger scale, that's what we see at a drinking water plant.
All right, very cool. Yeah, I really want to have a discussion, even more of a discussion about size. So size is super important when we're thinking about drinking water treatment, and actually everything else in the environment. Size really matters. Now, a bacterium, you all probably have learned about bacteria, and you know that bacteria are super tiny. But how tiny are they? Like, what is the size of a bacterium? Well, let's imagine a bacterium is this big. This would be 2 microns, typical bacteria are about 2 microns in size. Now, if I'm going to remove a bacteria from water, that means I need a filter with holes that are smaller than that. So the holes in these filters right here are 0.45. That's almost half. It's about half of a micrometer. So if this is a bacterium, then the hole in the filter is only about that big. And so this big bacterium can't get through the hole. And that's what the filter is all about. I mean, that's a pretty simple concept, I guess. But the key is we have to realize that if we're pushing a lot of contaminated material through the filter, then we're going to clog the filter up and block those holes. But as long as we keep maybe cleaning the filter, and we do what we call backwash to backwash the filter out, and we can keep purifying the water and removing the bacteria. And then the other key thing with size is the cloudiness that you see. We only see cloudiness for particles that are larger than 0.45 microns, because that size is what scatters light. If something is too small, then it won't scatter any light. We won't be able to see it using light. And that means it's dissolved. So there's still stuff in this pure sample, like there's sugars from the hot cocoa mix, and there's salts like sodium chloride. Well, all of that is smaller than 0.45 micron. That's why you can't see it. It doesn't scatter light. But hot cocoa mix does have a lot of stuff that's larger than 0.45 microns. A lot of what you drink in hot chocolate is particles. It's a bunch of little particles that are larger than 0.45 micron, and they do scatter light, and that's why we see cloudiness. That's what we call turbidity, when light gets scattered. That's turbidity. So filtration is a great way to remove turbidity because it removes particles that are larger than 0.45 micron. You have 2 filters, so if one of them gets clogged up, you can use the other one. But, after this activity, you can try other things. You could go get anything else. You could get some dirty water from a puddle outside, or you could try, I don't know, any other things you could try in the kitchen, stuff that you might be able to filter out. Ooh, you could try milk. Try some milk. Now, milk is interesting because there is stuff in milk that's larger than 0.45 micron, but there's a lot of stuff that's smaller than 0.45 micron too. So a lot of the white stuff, the casein, the proteins in milk, will actually go through the filter. So you might not be able to get pure water out of it. This is really the experiment. Anything that passes through this filter will be dissolved. Anything that doesn't pass through the filter will be suspended.
Right. So I chose environmental engineering because, as a lot of people would like to say and agree with, I care about the environment and keeping the environment safe. And then I also care about people and keeping people safe. So environmental engineering is just a really good segue to make sure that whatever humans put into the environment, we make sure that we clean it up. We want to make sure that the environment lasts for a long time, but we also want to make sure that humans are staying safe. So like I was saying with the smog and the industrialization that's happening, we want to put a cap on all of those contaminants that are going out into the air or going out into the water. It used to be a thing where people would literally dump chemicals into bodies of water. They're like, oh, the ocean's so big, it'll dilute all of these really bad chemicals. But now science is telling us that's not true. It's affecting the ecosystems, it's affecting the food chains, and in turn, it's going to affect us. So the earth is the only thing we have, so let's keep it clean.